So now we're going to look at naming acids. Now, the way you know something is an acid is it's going to have an H on the front of it and an AQ at the end. So see H and then AQ. It would look more like these right in here. You know, those are acids, and also just any of these with that H on it. So that's the look of something as an acid. And acids are a little bit unique on how they get named. They are a positive negative situation though, so you can still figure out how many, how these acids, you can still figure out information about them. And like, for example, if you're going to try to figure out how many, let's see, H's will go with Se. H is always +1. And then Se, it falls in this category over here. It's the -2 category. And so you will need 2 H's to balance out that charge, so that you have the 2+ and the 2-. So you can do that with H's. Just remember, all H's are +1. It's usually the H that you have to have lots of when you're doing acids that have different charges other than -1. When the anions have charges other than -1. So when you're just doing the acid and the nonmetal, kind of like earlier, we had the positive stuff and the nonmetal, or up here, positive and nonmetal, the name, it's going to have an ending, but "ide" is already taken. You know, like up here, "ide," that ending's already taken, and it's already taken here. So instead of "ide," the ending is going to become "ic." So we use "ic." And this is really weird. Before, we would put the whole name down. It'd been like hydrogen chloride if we had been doing it that way. But since this is an acid, we don't name it the same way. We use hydro to kind of represent the hydrogen part of it. Hydro, and then it's all one word. So chlor for the chlorine, and then ic, and then the word acid. So pause the video for a minute and see if you can figure out what H2S would be. Hydrosulfuric acid. And then look at H2Se. This is selenium. Selenic acid. Now try HBr. Hydrobromic acid. So hopefully you're seeing these are all a trend. This is how you name it. Again, if it's just if it's just H and an element. H and an element. Just one type of element. There can be more than one of those elements, but like it's just like one type of element. I don't know if you can have more than one of the elements, but it's just like one element is after. You look on the right-hand side, there's elements and there's oxygens. So this case, all the cases, except for this case, the polyatomic ions, you just put their name down. But in this case, you have to pay attention to what the name is. It's kind of odd. So you actually don't say anything about the hydrogen when you're doing the polyatomic names. You go and you look up the name of it. So let's see, NO3 is right up here, and so it's nitrate. Do you see how it has an ATE? So the ending matters. ATEs are becoming ics. So like ATE, that would be an ic. That would become an ic. That would become an ic. Do you see how I'm kind of, all of these endings that have ATE would become ics when we're talking about acids. There's some over here too, on the left-hand side. So nitrate, that's a nitrate group. So it is nitric acid. So again, that's nitrate becomes nitric acid. This is perchlorate. That's its name is perchlorate. That's what he is when he becomes an acid. Again, it has that ATE ending, and so it becomes ic acid. Now I'm going to give you another one to think about. What about H2CO3? That's this one. And then also figure out H2CrO4. It's right here. So pause the video. You want to have gotten carbonic acid and chromic acid. Now let's get to the other one, HNO2 and ClO2. So these ones end in ite. Ite. Find another ite. Ite. There are more ites out there. Here's another one, ite. So the ites become us. It's weird. Sounds like a crazy naming system. Nitrous acid, because it was nitrite. Now you figured this one out. It's up here. And you should get chlorous acid.